Hello everyone, I am Mallikarjun Rao Mudigonda, and in this video I'm going to cover about packet deduplication in the context of packet visibility using Nexus Data Broker product. In this video I'll touch upon what are the different ways that you can use this feature and what are the different switches that support this feature and various ways that you can deploy this feature in the data center in the context of packet visibility. So let's take an example. I have a data center here, and so due to various reasons, the way how you put the tabs in your data center, or because of the TX and RX rules, or the types of configuration you do on the span, on the leaves, there is a high chance that you collect the repeated packets through span and taps, and you bring those copy data to the Nexus Data Broker switch. In this example, I have a tap in between my leaf and the spine, and I also have a tap in between my WAN aggregation gateway and my spine. So what happens is if I put a tap in two locations, the amount of packets that you bring in from tap A and tap B are deduplication or duplicate packets. You bring those two copies to the Nexus Data Broker, and now what happens is if you send those packets to your NetFlow collectors or to your tools, so your tools are getting overwhelmed and your NetFlow records that you collect from these raw packets is not accurate. So when it comes to the span as well, when you configure a local span or a tenant span or a fabric span in your data center, so you usually configure the span using the TX and RX, and sometimes you do a span configuration with both the TX and RX. So when you do that, depends on the span where you configure, on what leaf you configure, and depends on the source interface, you end up choosing, or you end up getting lots and lots of duplicate packets to your packet visibility network, and those packets are going to be a killer to your tools, and your net flow is not going to be accurate. So we need a solution to kind of do this deduplication in the tap aggregation network, in the visibility network. So we don't want our leaf spending more and more cycles on doing deduplication. So we need to get the raw packets from various points through span and tap, and we can use an Nexus Data Broker to do a deduplication for us before ingesting them to the NetFlow collectors or the tools. So let's take a look like on what switches we have this feature. On pretty much on all the cloud scale switches, FX2, FX3, GXN, GX2, GX2A and GX2B, we have this deduplication feature available on the NXOS. And this feature is available, and the only thing that is still pending from the controller side is we still are implementing or automating this feature from the controller, but we can manually configure this configurations on the Nexus 9K switches and get started with the deduplication feature. And here are some of the interesting callouts about this feature. Based on the deployment models you have, based on the adoption you have, say for example, you're getting started with the Nexus Data Broker product, maybe you want to think about the greenfield usage of the packet visibility, we have a deployment model for that. Maybe you're already a Nexus Data Broker solution, have a brownfield packet visibility network already built in your data center, we have a brownfield deployment model for you. So say for example, your taps and spans are getting encapsulated packets, we can do a deduplication on the inside packets after removing the tunnel headers. Based on the switch that you select, the deduplication is supported up to 12.8 terabytes of packets. And we have various stats for the deduplication feature to show how many packets or percentages of packets that you see in your data center are duplicates. And at any given point of time, again, depends on the switch that you select, we can do a deduplication for approximately 128K flows at any simultaneous point in time. So again, coming back to the deployment models, we have an inline duplication model where you are getting started with the product and you want every switch, maybe you can think about this as a greenfield deployment. On every switch you want to implement the deduplication. Once after you build the visibility network, you can turn on the deduplication feature on all the switches as shown in the topology. So every switch now, after getting the raw packets through taps and spans, is going to implement the deduplication feature before ingesting to the tool ports. And the other model that we're talking about is the deduplication on the stick model. So this is more interesting when you have a brownfield deployment. Maybe you've already built a NDV topology, and what you can do is you can just bring a new switch, a capable switch. You can turn on the feature and then just plug in that to your existing topology. And now this switch is just going to be a dedupe on a stick model. It implements all the deduplication for you and bring back all the packets to your visibility before ingesting to the tool ports. It's a quick insertion model where you need to very less disruptive in nature, but this is more suitable for the brownfield deployments. And depends on the amount of deduplication that you're planning in your visibility or from the visibility context on your data center. We have various ways that you can think about, right? You can do a deduplication feature on every box of the topology, or you just bring one insertion switch and plug it into your existing visibility network and you start configuring the deduplication on that switch. Or maybe you want to have a huge amount of span and tap traffic coming in into your tap aggregation network, and you want a farm of deduplication switches. We can horizontally plug them and cascade them to ensure you're spraying out the packets to your deduplication cluster and again bring them back to the visibility topology before ingesting to the into your tools. And so deduplication feature can be enabled on local span, and the optical tab bringing in the raw packets. And once you're getting the packets of tunnel in nature like VXLAN, IVXLAN, GRE, ER span, the first thing what we can do is we can remove all your tunnel headers and ensure that deduplication is enabled on just the inside packets. And this is all done in the and done in the hardware and in the ASIC. Unlike some of the competitive solutions, we don't need any x86 servers with a special licensing or a farm of servers to implement this. It's done very simple mode of deployment. It just enabled on the switch and the Nexus 9000 itself, and you don't need any special licensing or a special hardware or a special handling with any LEM cards or any fancy hardware in the product. And deduplication is done on the inner packets. And for deduplication, we consider the 5 tuples: the source MAC, the destination MAC, the source IP, the destination IP, the source port, and the destination port. Based on the way how you enable this feature, either it's an interface model, which I'll talk in next few slides, the interface model, or on the VLAN model. So we consider in some use cases the VLAN as well, or just on the interface itself. And the other thing is, now this is all done in one pass. The tunnel terminations, removing the headers, and just running the deduplication on the inside packets is now done on the single pass on everything on the hardware without a need for a special hardware. And once after deduplication, we can enable all other features like the net flow or replicating it to your tool ports. So that way, the net flow that you generate from the raw packets after deduplication is more accurate now, and the packets that you are ingesting to your tools is now more control. You are not sending any duplicate packets. The tools are also not getting overrun because of the deduplication feature. So here are the quick snapshots about how much time it takes for the switch to learn the flows that as and when it comes in taps and spans. As the table is more self-explanatory in nature, it can range approximately. For one flow, it takes like approximately 100 milliseconds, and imagine you have like 128k flows simultaneously coming in. All it takes is 10 seconds to learn the whole 128k flows. Depends on the model you select. As we initially talked about, this feature is implemented on all the cloud scale switches. Depends on the switch you select. The flow scale varies all the way from 128k flows to all the way to 240k flows. Say for example, you anticipate more and more packets of having duplication in nature in your data center. Maybe you have to think about a switch which got a capability to learn more flows and implement the deduplication for the more flows at the same time. And here is a quick illustration where I'm trying to explain with the topology. I have two switches and I have two use cases. My use case one is I have a allow tool hanging out of my switch one, and I need all the packets. I need the duplicate packets, I need everything, right? And I have a blue tool which is connected to my second switch, is very sensitive to the duplicate is very sensitive to the duplicate packets. I need just the unique packets. So to illustrate this, I have uh, two feeds coming in, the tabs which are 2 Gbps and 2 Gbps, and now all the packets are sent to the allow tool. The allow tool will have 4 Gbps, and my blue tool just receives only unique packets. So here are some of the captures that I got from my tool side, which I collected from a traffic generator, where my allow tool is receiving 2 plus 2, which is 4 gigabits of traffic, but where my blue tool is only receiving only one feed, which is the unique packets, which is only like, and this feature is available from 10.4.1f, and no new licensing are required. And here is the link to the configuration guide. And again, calling out again, like the controller still did not automate all these features from the controller side, but you can still manually configure the deduplication feature on the NDB.